Assalamualaikum and a very good day. Introducing our group members from Group 12, Siti Hajar Abu Sama, Nurul Rakiba Ridwan, Nurul Nazira Muhammad Izan, Ahmad Shafi Salihin.
So this is our journal that we have chose, which the title is Domestic Wastewater Treatment Using Effective Microorganism Technology. So the purpose of the study is to identify the effectiveness of effective microorganism in treating domestic wastewater by reducing the biochemical oxygen demand and chemical oxygen demand using the activated EM solution. Some question of the study did not answer is: first, the making of the effective microorganism. The EM have no detail about the production and only explain the method to activate the EM. Next, differences between effective microorganism and activated EM solution. In the journal, no explanation about the differences and when can it be used. For the next one, reduction of odor methodology. The journal stated in the introduction about the odor smell, but no detailed methodology to measure the odor. Last but not least, parameters involved is too general for domestic wastewater measurement. Parameters such as total phosphorus and nitrogen, which can be used to measure the wastewater are not included.
So what is the specific question we address and how in this paper? So the removal and disposal of household solid waste and wastewater is a major issue to the community, where it leads to the environmental and health problem. So as you can see here, the solid waste which goes to landfilling or incineration plant. For the domestic wastewater, it goes to wastewater treatment. However, this treatment of waste are not possible to use at the local level, and this current technology is only used in order to dealing with the problem of the generation of waste in a high volume. So this paper proposing using effective microorganism EM to treat the wastewater and also the solid waste, which can turn it into useful product.
In this study, there were 4 significant methods were used. The first one is selection of study area for wastewater treatment. Study area is the first and most critical parameter in this project. They began by deciding on a research area for treating domestic wastewater, and the result, they choose the domestic wastewater collection research area in the Samad College cantonments for wastewater treatment, because there is a lot of wastewater produced on a daily basis. The second is the collection of wastewater. The collection was obtained from the Samad College is a sterilized plastic container. The wastewater was taken to the laboratory for examination as soon as it was collected. Physiochemical and microbiological tests were performed on the collected wastewater sample. Then, collecting and activating the effective microorganism solution. Effective microorganisms are available in a dormant state that must be enabled before use. The temperature of a microorganism's atmosphere has a direct effect on their survival, with significant temperature variations affecting their survival. The pH of the wastewater is also a deciding factor. Treatment of wastewater is the last of significant method were used. After triggering the EM solution, wastewater treatment is carried out and various tests are carried out to investigate various physical and chemical properties. After the incubation time, the effect of EM was measured by changes in odor, pH, biological oxygen demand, chemical oxygen demand, total dissolved solids, and dissolved oxygen. The findings were discovered and the different methods to be used for treatment were determined based on pollutants present in the wastewater. Agriculture, poultry, planting and landscaping, composting, bioremediation, cleaning septic tanks, algal control and household waste are all possible applications of EM according to studies. Total dissolved solids were reduced from 2,305 mg per liter to 1,110.5, 904 and 885.7 mg per liter respectively. Alkalinity was reduced from 55 mg per liter to 43, 34 and 23 mg per liter, and pH was reduced from 10.2 to 8.5, 6.8 respectively. The BOD levels were decreased from 2.42 to 2.22, 1.42 and 1.04 respectively. The amount of DO in the air was not reduced. At each incubation period, the COD was reduced from 168 to 140, 180.4 to 108 mg per liter. The studies were carried out in accordance with ISO guidelines. These figures reflect the average of three different measures.
The particularly striking findings of this study is that composting has been shown to be a viable option for domestic solid waste disposal, but it can be difficult to implement. Despite the fact that all of the references stated that effective microorganisms have a lot of potential for speeding up the composting process, the mechanism of microbe reaction to organic waste is subject to a lot of uncertainty, which prevents this problem from being discussed in most of the references. As a result, further research into the use of effective microorganisms in domestic solid waste composting is needed. In effective microorganism organic composting, the time-consuming and repetitive process can become a challenge. However, if the use of electromagnetic fields to speed up the composting process is successful, it can minimize the amount of domestic solid waste disposed of in landfills. Environmental degradation occurs as a result of economic growth by industrialization and agriculture for the betterment of our society's future. The aim of this study was to see if one of these new techniques, which is effective microorganisms, could be used to treat wastewater. The metric is pH, DO, BOD, COD, and TDS were measured before and after wastewater treatment to determine the efficiency of the chosen procedure. Other liquid waste management companies have seen a significant reduction in the above mentioned prices.